This is a high-resolution analog input extension board. It has 4 channels, and each channel has a 16-bit of analog input. And there's also high-precision resistors for resistive sensor sensing. So let's get started setting this up. We'll start with the standoffs. So we'll take 2 small washers and just put on the standoffs, because that will just prop the board exactly the right height. We'll take these nuts. These are all M3 hardware, so they're 3 millimeters in diameter. So that's 1, 2, and you can have as many as 4 of these boards stacked on top of your regular SDI 12 USB adapters, and each one can have a unique address, and the address is set here. There's an example here how to set an address to 1. So at the moment it's on address 0. So you can have as many as 4 boards addressed from 0 through 3. This one's set up at 0, and by default, the 0 will actually have 2 sensing commands, the ZM and the ZM1. The ZM is sensing all 4 channels as single-ended input. So that's the most typical sensing command. And the ZM1 would be using channel 0 and 1 as a differential pair. That is if you want high precision and you actually don't have a lot of sensors to sense. If you only have up to 2 sensors to sense, so using that can give you better precision. Let's see, this is, maybe it's, this thread is not very good. What happens here? I think it's just the standoff itself. Use a different one. Maybe the thread is not working too well. Okay. So the very last one. Okay, so this is set up to make connections, and I also have 4 jumper wire, these little jumpers or shunts. So what you can do with them is, if you have a resistive sensor, for example, if you have a thermistor, a 10K ohm thermistor, and you can use that over here, just connect that between a 0 and a sensor channel. So let's flip over here, maybe this way. And you can see some markings right here, 3 plus minus, 2 plus minus, 1 and 0. So the plus is the USB 5 volt, nominal 5 volt, and the minus is ground. So if you have a resistive sensor, you can go between, say, channel 0 and ground, and then between channel 0 and 5 volt, you can engage, for example, this way, 0 to H. There's actually markings here. It's a little harder to see with this camera setup, but let's see if I can point to it. So here's channel 0 right here, it's at 0, and this is H high. So this connects H the high with 0, which means it is going to use this 10K precision resistor, so that you'll be making a resistor voltage divider with a 10K precision resistor on the higher voltage, and then your resistive sensor on the lower voltage side. So you'll be able to read the this voltage here and calculate back the resistance. And if you have something that's near 1K, and there's also a 1K precision resistor you can use, you can just pop this out and put it on the other side. So this connects the 0 channel with the lower resistor, which is the 1K precision resistors. And now these resistors are actually quite precise. They're 0.1% accurate, and the part per million of resistance change per degree C is on the order of dozens. So it's relatively stable even with a large temperature span in outdoor temperatures, compared to what these other resistors that you typically see. They're at best 1%, and the temperature coefficient is unknown mostly. And these are for just pulling up logical levels of digital circuits. So that's why I have some of these over here that are just typical for digital logic 1%, and these are 0.1% with high temperature stabilities. So now that this is set up, if you have analog sensors that don't really have a resistive output, then you don't really need any of these. What I will do is I will take a small bag and just dump them all in here, seal the bag, and tape it to the backside of my data logger enclosure. So I always have these handy in case I need them. And I can also put in some additional hardware just in case I dropped some. So this will go nicely on the inside of an enclosure. Okay, so now this is set up. We can just use this on top of an existing adapter here. So for this one here, because the adapter doesn't come with the pins already soldered, so what I would do is I would put the pins over here and push that in and just solder on the back side.